Okay, normal Sudoku rules apply. So digits 1 to 9 in every row, every column, and every 3x3 box. Actually, can you guys see the clues? Oh yeah, you can. Okay, sure. You can see the numbers here. Actually, there's only 2 clues, mostly. 2 big numbers to worry about. Sorry. Then we have modular lines. So along these teal lines here, every set of 3 adjacent cells, so for example those 3 cells, have to contain digits with different remainders when divided by 3, which are 0, 1, and 2. Okay. So I guess let's do an example or something, I don't know. If this is a 4, oh sorry, I clicked a 5. If this is a 5, that could be like a 9, and this could be a 7, I think. And then this works because this is 2 mod 3, this is 0 mod 3, that's 1 mod 3. And basically every set of 3 along here should be, you know, that. Okay, I'm just gonna assume that these, like, they don't cross or anything, they just go straight over each other. Yeah, continue straight through intersections. Alright. And then little killer. So clues outside the grid give the sum of the digits along the indicated diagonal. So these digits in total sum to 69, basically. Nice. Alright, anyway. I think with that we shall start solving, because I can already tell what you can do here. It's a very interesting fact about mod 3 is because those 3 digits are all different mod 3, right? So one of them is 0, one of them is 1 mod 3, one of them is 2 mod 3. If you happen to add them all together, then by modular arithmetic, they sum to 0 plus 1 plus 2 mod 3, which means they sum to 3 mod 3, and therefore the total value of these digits are 0 mod 3. The total sum of these digits are 0 mod 3. And we can do that for these here as well, and we can do that for here as well. And then we can say that therefore all 3 of these sum to a multiple of 3. And I think I can do the exact same here. So what does that mean? No, I don't think you divide by 3. No, because they could sum to different values as long as they're all mod 3 though. But this has to be pretty high, right? Because 24 is the maximum you can have in 3 different cells. So the maximum you can have per set here is 24. But obviously if all 3 were 24, you'd have like what, 72, and that's way too high. So one of them has to be slightly lower, or at least one has to be slightly lower. But if you make 2 of them slightly lower, you'd get 24 plus, I think, 21 plus 21, which is what, 66? And that's also not enough. So I think the only way to make this work is if you have one set that adds to 24, and 2 sets that add to 21. Wait, sorry, no, 2 sets that add to 24, and 1 set that adds to 21. Yeah. I think that's the only way to make it work. Okay, let's probably do the same thing here, right? Because this is actually rather on the low side. So, if all of them were the lowest possible, which is 6, then obviously it's not enough. But if 2 of them were slightly higher, if you had 6 and then 9 and then 9 again, that will add up to what? That will add up to 24, which is way too high. So that means that I think you can only have one that's slightly higher. So it has to be 2 6s and 1 9, which do add up to 21. And the 2 6s must be 1, 2, and 3, but this one can't be 1, 2, 3 because there's already a 1 in the box. So these 2 sets on the outside must be the ones that are 1, 2, and 3. And on the inside has to be a 9, which I think has to be 2, 3, and 4, because you can't have a 1 in it. Yeah, okay, which is good, because that leads us back to this set over here, which we said needed 2 sets added up to 24, but those 2 sets need 7, 8, 9. So they can't be the middle set, because the middle set does not have a 7, 8, 9 here. Which means that the two 24s have to be on the outside, which have to be 7, 8, 9. So now the middle has to add up to 21, right? Yeah, and the maximum you can make it is 8, 9 here, and a 4 there, which is 21. So this in fact has to be a maximum. So those are 8 and 9. That's 4. Ooh, I like this logic already. So that's our first digit. Very fun, very fun. So I guess we can place our last digits down, which are 5, 6, and 7. And that's not 6. Okay, you know what? That's basically the every little killer we get. I don't think we touch the little killers anymore because we have everything in place already. So that's all the help from the little killers we're gonna get, which means it's all mod lines from here. Oh no. So those two are different mod 3. And you can see the same thing about this. Oh, sorry, we can do this one first. Sorry, that's 1 mod 3. I'm just gonna color that one random color. I think we've always been doing orange is 1 mod 3. So let's do that. And then pink is 3 mod 3. Sorry, not pink. Blue. You know, whatever. I don't think we need to assign colors right now. So let's just do that. How does that help? Then it implies that these two digits are not 1 mod 3, and therefore this digit has to be the 1 mod 3. Same for here, this digit has to be 1 mod 3, and then these two digits have to be 1 mod 3 as well, because they are an equal distance, or they're 3 away from the center, which is 1 mod 3. So those have to be 7s, because 7 is the only one that's 1 mod 3 there. Those have to be 1s. Ooh. This is actually really exciting logic. I don't know why. I found that very satisfying to figure out. Okay, I think we can talk about this one now then. No, we can't, sorry. No, we can't, because this could still be 1 mod 3. Yeah. I was like, this is not 1 mod 3. This could be 1 mod 3. It could. This could also be 1 mod 3. So we don't actually know how it goes yet. I think let's remove the color here first in case we need to randomly assign one to each. I mean the 147s look at that cell, which isn't on a line, so that's not very helpful. But we can say that those are definitely not 1 mod 3, because they're all seen by 1, 4, and 7. I don't know though. Actually, we do know that one of those are the 1 mod 3, right? Because it's not the middle one. So one of those are 1 mod 3, but they're not 1 or 7, because 1 and 7 see both of them. So like, I guess I can put 4 here, say one of those are 4s. I think we can also say the same here, right? Because if this is 1 mod 3, then this is 1 mod 3. But if this is 1 mod 3, then this is 1 mod 3. So again, one of these has to be 1 mod 3. But whichever is 1 mod 3, it can't be 1 or 7. So that will have to be 4 as well. So doesn't that make this sort of cool looking thing here? Yeah, I think this is right. That doesn't help. I was like, well then any line in the row or column can't be 1 mod 3 anymore. But there is no such line. So that's very funny. I guess what that means is that this isn't 1 mod 3. And then same for this isn't 1 mod 3. Which gives us slightly more to work with. But again, it isn't much. Is this puzzle indigestion? I think it is. Yeah, it is indigestion. So again, this shouldn't be insanely challenging, but it's probably gonna have something funny going on in it. Okay, actually if this is 1 mod 3, it must be 7. That must be 4. Which means that... Sorry, all those... Okay, let's think about this one. Oh, those are the same mod 3. But I think this digit and that digit is the same, right? Yeah, those three digits are all the same. Because this digit and this digit are different. So these digit and this digit are the same. And then we can do the same thing here. And those digits are the same. Which means that whatever that is, it can't be in those digits. What does that mean? Doesn't that... you could have so many options though. They could still be the same digit. They could also be different. Or I guess, are these the same? Or these... No, these are different. They both see those, but those are different digits. Yeah, those are different. Okay. If they were the same, it would probably be helpful, but they are not the same. I mean, those are the same. Does that help? Those are the same? Kind of tells you that now those are that particular digit, which means it has to be here somewhere. But no singular digit at all in general. Yeah, okay. Okay, give me a little bit more time to stare at this first. You know what? Actually, are these independent of each other? Are these lines independent? I think they are, right? So we can't actually say that just because this is one particular sequence, this has to be the exact same sequence or something else like that. They don't do that. And I don't think I can see anything that leads to any conclusion like that. Except maybe like it goes somewhere far away, points at this cell. And then comes back here. No, okay. I don't know if I'm otherwise just missing simple Sudoku. I mean, 7 is one of those cells. What if 7 was like on a line here? That doesn't work because that's not mod 1. Right, so this is not mod 1, meaning that 7 in this box can't go there and therefore must be there. Which is mod 1. So maybe that's helpful. I don't see it immediately though. I don't think it is. Well, you could probably do the exact same thing here. Yep, where 7 sees those cells. This can't be 7 because it's not the same mod as that. So this is where 7 is. Someone could be anywhere there. And someone could be anywhere there. Okay, so I don't think we can do any more of 7s, but... that was an interesting find. That those cells are definitely not mod 1. Can we do anything with the 1s now? No, because the 1s see those cells, but they don't have any line to restrict it at all. I feel like that does something, but I don't see what it does. The 7s. Sixes now? No, 6s still have a lot of options here. Because 6 could be anywhere there. I think 6 could even be there if this was like a 9 or something. Okay, well, one of those cells are 4, which points in those cells. This cell can't be 4 because that is not mod 1, so 4 is in one of those cells. And I think we can do the exact same here where 4 looks into one of those cells, this cell can't be 4, so 4 is in one of those cells. Which what? They point here and here to say that one of these cells are 4. Ah, and the 1 does the exact same thing. 1 here and here points in those cells. So these are 1 and 4, which are both mod 1. 1 mod 3, sorry. So that's something. And then these are 8, 9. So we have... Well, I guess 6s over here must therefore be one of those cells. Which means what? It sees those cells. It could still be there again. Once again, it could still be there if this was like a 9. So... Okay. What are we missing? 2, 3... 2, 3, 5, and 6. I see. 2, 3, 5, 6. 5 here? 5 is in one of those cells. I think 5 can be there if 8 was there. So this is like a similar issue with the 6 here. Yeah, and then 6 is in one of those cells, so it's not a 4, 5, 6 triple. If I could find another digit that goes into those cells though, that would be a triple. But I don't think I can find anything there. It's like 8 and 9. Not really. I actually think that coloring is gonna be a lot less helpful here. Although maybe it's not gonna be. Maybe it's always just coloring. Coloring always does something. I mean, should I even try? Let's just assign this a random color. Does that do anything? We can color all those, and then we can color all those. But what does that mean for the 2 and 3? Does that say anything? I don't think so. Except one of this is mod 4 and one of this isn't, right? You can't have both of them be mod 4, you can't have both of them be not mod 4. So one of them is mod 4. Which means what? Well, if this is mod 4, then this is pink. But if this is mod 4, then this is not mod 4, which means that this must be mod 4. So can we say that these all can't be blue? Wait, why no, this could be blue. Sorry, this can't be pink. Oh. Hold on. I'm not sure if this is helpful or not. But this is one of those, and then these are just one of those. Is this a pair? Yeah, yes, it is a pair. It is a pair. But it doesn't say anything about that because we need like 3 to say anything about that. Okay, this coloring is going a bit wild. I don't know if that's helpful or not. Recommend coloring? Huh. Okay. I mean, we could do the exact same thing on the opposite side. But, well, what does that do? How many oranges do we get here? Is it always 2? I think it's always 2, right? Because there's always 1 orange here. Oh, so it's not always 2. There could only be just 1. It could be this one that's orange, and then now these are orange. Okay. And then this is also 1 or 2 only. What am I supposed to color though? Okay, I'm gonna remove the colors first. I will say this is pretty interesting if this was blue as well, because then you'd have a full set. Wouldn't you also have a full set if this was blue? And then these are not the same, right? So you always have a full set either way, whichever one of these were blue. I should probably color these again. Although I can't, because I don't actually know what they are. Like, I don't know if this is mod 2 or mod 2 mod 3 or 1 mod 3. 2 mod 3 or 3 mod 3. So I can't color. Unless I remove all these color. And then I say, this is blue. That's pink, which is I think the color that we were using in the previous puzzle. Oh, this one, okay, I'm dumb. This one can't be a 147, so this is not mod 3. There we go. This is not mod 3, that's not mod 3, so these are the ones that's 1 mod 3. Okay. Cool, so this one's mod 3. This one's the last one. Okay, there you go. Which means we get a couple more digits in. So those are 4s, those are not 4s. This can't be 4 or 7, so it's 1. Yay! I don't know if that was because it was tough to see or if it's just because I wasn't staring hard enough. So 4's in one of those cells, I think that's fine enough. Actually, 1 is also in one of those cells, so this forms another 1-4 pair, which is also always mod 3. And I don't know if coloring is useful now. Bro, I think it's very funny that my family is watching a horror movie outside. I think, from what I'm hearing, I think they're watching a horror movie outside. Anyway, these are 2, 3, and 6. Oh, this 5 probably helps. Nah, just kidding. I don't think so. So that's the last one. This is also the other one. And then I think these are all the same mod. So I'm gonna remove the colors once again and try coloring again this time. See what we get. Also, those are different. Okay, this is blue. That's pink. That's blue then. I mean, it's also blue. That's pink. No, it doesn't. That still doesn't tell me anything. Although I guess, what do I guess? If this is blue, that is also one full set, which I can't say the same for that. There's some very weird there's some very weird thing you're doing with this antenna, because even though it's symmetrical, it's not at all symmetrical in mod 3. I think it's because of like a significant difference between you know, mod 3 and mod 2. If it was in mod 2, then yeah, it would be symmetrical, like the coloring. But no, this is mod 3, so the coloring isn't symmetrical either, which is very interesting to me. I don't know, I find it cool, I guess. Okay, but I actually don't know what I'm supposed to do now. Can I do more regular Sudoku? I don't think so. Not the 1s right now. Not the 4s either. Yeah, not the 4s either. And the 7s don't give me much help. No. Oh, I'm sorry. This one sees that. What am I doing? Actually, how does this one even see that? That's so weird. I never actually realized that. But this now can't be a 4 then. Meaning 4 goes there. And I'll just color it. for completionist sake. So that's another full set. Anything else that I'm going to eventually miss? We'll figure it out. Can I do more with the 4s now? No, still can't. Still cannot. Oh no, sorry, this 4 sees that. So yes, I can do more. Just slightly more. I don't think that does anything else in particular. Yeah. Okay, so all of these are now... Actually, I think the 4s, yeah. The 4s and the 1s. The 1s and the 4s, they all see everything but that. So this is a 1-4 pair. Which means 7 is now... 7 in this... Oh, 7 could still be there, right? I didn't see that. 7 could be in one of those two cells. Okay. Can we do the same like somewhere else? No, I think that's all we... Oh, there's one here as well, yeah. The 1s... See, the 1s can now be in 4 cells, which is not where I want it to be. One of these cells is a 1. And the 4s are one of 2 cells, so I can't make another pair anymore. Because for some reason I can't put a 1 there, even though I can put a 4 there. Like, what? Okay. Can I place a 7 here? No, 7 is one of those cells. One of those cells in here. And then 7 can't be there. It could be anywhere in those cells now. So that's even worse. If only though. If only. Well, that's fine. We're slowly getting into it. We're slowly getting into it. I gotta keep myself looking at this though. Okay, what now? What now? Actually, whatever color this is would complete a set. Right? Yeah, it will complete pink like this, or it will complete blue like this. I don't know why I'm so focused on that. I don't know if that actually leads to any useful deduction. Like saying that if this is blue, then none of this is blue. Should I put in all the rest of the digits? What are those digits? 5's in one of those digits. 5's in one of those cells. Because of that. Because 4 is there now. Can I do the same with another digit? This is what? 5, 6, 8, 9, right? No, I don't think so. And then these two digits are different. So in fact, this can't be 8 or 9. Because whatever this, if this is 8 or 9, then whatever this is would also be there. So this can't be 8 or 9. What? Could it be 5? I mean, yeah, because then these could be 8. Or am I hearing car horns outside? Car horns. Sorry, I'm getting carried away. Where? 5's in one of those cells. What else is in one of those cells? 2, 3, 6, 8, 9. 2, 3, 5. Okay, so 5 is the only one we can confirm in those cells. Actually, these are the same, right? These are all the same digit. Maybe that does something. Yeah, yes, it does something. It makes this a pink. Because those digits look at those cells and are a different modularity than this. So this cell must be where it goes and must also be pink. So that's, I think, an 8, 9. And then I think we might be able to do the same thing up here. No, just kidding, we can't. We'll probably do it with the blue, maybe? Because these blues see all those cells, meaning that it must be there. So this is also 8 and 9. Yeah, I should remember that, actually. So this is actually not 8 or 9. So these are all the same digit. Same for these cells being the same digit. But I don't see... Well, what happens here? They can't be anywhere there. But they don't do much else. Okay, what about here? Yep, these two digits, they see those two cells, which means that these two digits must be there. Let's just use a new color, just cause. Let's use green. I'm tired of not being able to color. I'll make this like a yellow or something. No, yellow's not good. Red. Good enough. So that's not 6. So what about here? Well, it's one of those cells, which doesn't do much. But those two digits are the same, right? Which stares into this box. Oh, but the issue is that these two could be the same mod, I think. Yeah, that's what I was afraid of. I was like afraid of confusing the two colors. But these two digits could be the same. I was gonna put it here. Oh, but this one, these two digits are the same. Right, they look at all those cells. So this is in fact that digit. Okay. So now these 3 digits stare at all that. So that's the digit. That is where it goes. I could probably do something with... Could we do something? Maybe with reds. No, I don't think so. I mean, yeah. No, wait. No, these two could still be the same. Right, see, same issue again. But this thing over here sees one of those cells. Which works because one of those cells will always see those cells. This one sees that, this one sees that. So this is always going to be red. Which now allows these 3 cells to stare at all those, which means that's the red one. Which removes those cells, so one of those cells is red. Not the same as the green is from one of those cells. Well, I hope I'm still doing this right. The coloring is going a bit out of hand. But eventually something has to budge. I don't actually know what. Can I do anything else with these? See, now that I'm coloring those blue, right? That makes it way too confusing. Because now that it feels like those are also 8 and 9, which they're not. So let's actually just... I don't know what I'm supposed to do. So these 8, 9 see those cells, meaning 8 and 9 has to be one of those cells, or the blue digit, which now stares up there. This 8, 9 is not pink, it is not green because green is 2 or 3, so that is your 8, 9. Sorry, wrong color, I gotta use this one. Which forms an 8, 9 pair. So now these are 8, 9, which means the 8, 9 pair has to be there, okay. Wait, no, what am I doing? Wait, no, something's up. This is not blue. Because that sees that. Sorry, hold on. Yeah, I did something wrong here. I think I got confused by the coloring. Okay, actually let's just not do the 2 3s right now. Let's go back to the 8 9s and see what we can do with that. Because we know those 2 digits are the same. Therefore that digit would go here. These 2 digits... Well, no, sorry. These 2 digits are forced to be there. And now these 3 digits can see everything but that cell. So that is 8 or 9. I think we should start off with just one color first. And now these 3 digits, see that? So this is 8 or 9, which does form a pair. There's another pair here as well. I'm gonna remove those and see where else they look. Yeah, these 2 digits see all those cells, so they must go there. And now these 2 digits see all those cells, so it must go there. We remember that modularity is still this is still fine for modularity. We haven't talked about the 2 3s yet. So in fact these 2 digits are different. And then these 2 see those cells, so that is the last 8 9. So we sort of have that. And then we talk about these ones now. Those look at these 3. Look at those cells. So this one is where 8 9 goes. Then what? It goes in one of those cells, because this is not that. It goes in one of those cells. And then I think it's one of those cells. I'm not gonna figure out which at all. So that's probably it. But actually I can say that those digits, I'm gonna remove the color, honestly. Because I don't think we really need to focus on mod right now. That was probably a bad idea. But yeah, right now all the pinks are the same digit and all the blues are the same digit. So now let's work on the 2s and 3s. Okay. So these 2 greens see those 2 cells, therefore green must be there. Those see everything here, which means this must be where it goes. And then here we have those cells seeing that, so that's 2 3. And then here one of these are, and then here one of these are, and then here one of these are. Okay, that's not resolvable. What about the reds? I was like, can the reds be in those cells? I don't think so. Oh, hello, egg fried cheese. Hello. Welcome to the stream. I'm just doing a little bit of coloring right now. Although I'm having difficulty coloring for some reason. Somehow I am having difficulty coloring. Actually this cell, so 1 2 3 4 5, it could be 6 8 or 9. Okay, never mind. Row 6 column 7. You're just gonna say that? This one? Oh, am I being stupid? I think so. Yeah, you're right. You're right, this is just 6 in the column. Huh. Well, would you look at that? I can put those cells in. Those are 6 and 5. Actually, these 2. Yeah, we know that. We know those 2. Okay, that's fine. That's fine. This is its own thing. So 4. No, not 4. What am I saying? I'm missing 2 3 5 7. Okay. Honestly, not very sure where to go on. I can put those digits. Those are 2, 3, 5. If that helps. Yeah, whatever this is can't be in those cells. So it must be there, right? Yeah, okay. Should probably do that as well. So red now must go there. Which means that... Which means something. Yeah, which means red is here. Which means red is here. Oh, okay. Some interaction at this point. So red must be there. Which actually means that this digit is just 6. So now this must be red. Which I think gives us all our reds. It does. I think we can go back to greens now. Yeah, because those digits mean green is there. Which means this is not green or red, and therefore it's just 5. So green has to be here. So 6 is just there. And then I gotta color this green, and I think this has to be green. Yep. And then that digit has to be here, so this is 1 of 4. Actually, this 6 sees that cell. So that's 5. That's 6, which helps because that is 0 mod 3, which means all of these are now 0 mod 3, so they're all just 9. Which means that all of these are just 8. Okay. I think we are somewhat getting there. So if this is 9, if this is 0 mod 3, this must be 2 mod 3. So those are all just 2s. So those are all just 3s. Hey, 3 in the corner. Okay, I don't think we probably don't need coloring anymore. Although I might just find myself doing something dumb. Okay, that's 5. And then... Yeah, don't mind me, I'm just doing more stupid stuff. Okay, 5, 7, 8 here. Oh my goodness. Sorry, what is that? That is 2 mod 3. So it's 8, right? It can't be 2 or 5, so that's 8. No, what the? Oh no, sorry, that's 8. That's 2 mod 3. This is 3. This is 0 mod 3. My god, it can't be 6. It can't be 9 or 3, so it's 6. Okay, so that is 8. 8. So 8's in one of those cells. 8 here sees that, so 8 goes there. That means 8 goes there. Okay, we're getting there. This is 5 and 6, which we can place 5 here, 6 there. This is 1, 7, 8. Yep, 8 goes there. This is 1, 7. Thanks for nothing. This is just 6. So this is 5 or 7. Yeah, these are 5, 7. Okay, we're supposed to be able to figure this out. Oh, sorry, 5 sees that. That didn't really help. I was in one of those cells. Okay, hold on, I should just fill this in. 1, 4, 5, 7. This is not 1, 4. This is not 5. This is not 4. Oh my goodness. Yeah, this actually makes it a lot worse, doesn't it? Sorry, oh, sorry, this 4 sees that, so that's 1. 4, 1, 4, 1. Okay. So 4 goes there. 6, he actually sees that, so that's 7. 1, 7, 5, 6, 5, 7, 5, 7, 7, 5. Very nice. That was cool, actually. GG.